Involute is a curve obtained by drawing the locus of one end of a string when it is unwound from a polygon, example a circle, a triangle, square, pentagon, hexagon, etc., keeping the string straight. In this video, we will learn how to draw an involute for a circle. The problem statement is given as draw an involute of a circle of 50 mm diameter. Also, draw a tangent and normal line at any point on the curve. Draw a circle of diameter 50 millimeters. For one revolution, the circle will travel a distance of its circumference or periphery. Therefore, circumference ID is equal to 157 millimeter. 50 is the diameter of the circle. From the bottommost point of circle, draw a tangential line to a length of 157 millimeter. Divide the circle into 12 equal parts. For that, the procedure we discussed while drawing the cycloid can be used. Use the vertical and horizontal scales of the mini drafter. Draw vertical and horizontal lines passing through the center of the circle. Next, use the long edge of the 30-degree set square and draw a line. Use the short edge of the 30-60 set square, draw a line passing through the center of the circle. Use the longest edge of the set square, draw a line. Once again, use the longest edge of the set square in the vertical position, draw a line through the center of the circle, and the circle is now divided into 12 equal parts. Name the points on the circle as 1 dash, 2 dash, 3 dash, 4 dash up to 11 dash, and the 12th and bottommost point is named as P. The other end of the horizontal line is also named as P. Divide the line PP into 12 equal parts because the circle is already divided into 12. To have a uniformity between the division of the circle and the line PP, we divide it into 12 equal parts and name them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the 12th point is P. It is assumed the involute is drawn by unwinding a string in clockwise direction from point P on the circle. If we unwind the string through 30 degrees, keeping the string straight, point P will acquire a new position on a tangential line through point 1 dash. So the string is unwound, keeping it straight. Therefore, point P will go to some other position, and that position will definitely lie on a line which is tangential to the circle at point 1 dash. Therefore, to locate the position of point P after 30-degree unwinding, we need to draw a tangential line through point 1 dash. For that, use 30-60 set square like this and draw a line. So this line is the tangent through 1 dash. On this line, the point P will appear when the string is unwound 30 degrees in clockwise direction, keeping it straight. Similarly, for each increment in angle 60, 90, 120, 150, 180, point P will take a position on the corresponding tangential line through those points. Therefore, we need to draw tangent lines through points 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, etc. We may follow a similar procedure we discussed right now to draw these tangential lines. Through point 2 dash, draw a line like this. Through 3 dash, don't use a set square, simply use the vertical scale of the drafter and draw like this. Through 4 dash, draw like this. Through 5 dash, draw like this. And for 6 dash, use the horizontal scale of the drafter. Through 7 dash, draw like this. Through 8 dash, draw like this. Use the vertical scale of the drafter, draw a line through 9 dash. Through 10 dash, draw a tangential line. Through 11 dash, draw a tangential line. If the string is unwound through 360 degrees in clockwise direction, it will reach position P on the right end of the straight line. One revolution means starting from here, goes round, comes back here. So this is nothing but the circumference. So a string wound on a circle is unwound through 360 degrees will be of a length equal to the circumference of the circle. That's why we already calculated the length of the line as the circumference, which is equal to pi d. D is the diameter of the circle. So when you unwound the string through 360 degrees, point P on the string will reach here. If you unwound the string over 330 degrees, the point will appear on this straight line, that is tangential line through 11 dash. If you unwound the string through 300 degrees, then the end of the string P will appear on the tangential line through 10 dash. Therefore, to locate these different points, we start from 11. That means we assume we have unwound over 330 degrees. If you unwound by 360 degrees, the position or the end of the string will come over here, that is point P. Therefore, we start from 11, measure P11, the distance P11 as shown in figure, take 11 as a center, cut an arc on the horizontal or the tangential line through 11 dash and obtain point P11. Similarly, we need to obtain different points, that is P10, P9, P8, P7 on the respective tangential lines following the same procedure. Measure P10 with the 10 dash as center, cut an arc, obtain P10. Measure P9 with 9 dash as center, cut an arc, obtain P9. Measure P8, 8 dash as center, cut an arc, obtain P8. Measure P7, 7 dash as center, cut an arc, obtain P7. Measure P6, 6 dash as center, obtain P6. Measure P5, 5 dash as center, obtain P5. Measure P4, 4 dash as center, obtain P4. Measure P3, P3 dash as center, obtain P3. Measure P2, 2 dash, obtain P2. Measure P1, 1 dash as center, obtain P1. So P1, P2, P3, P4 up to P11 are the intermediate points of one end of the string when it is unwound from the circle. P is the starting point and this P is the end point. Remember, involute is a curve obtained by drawing the locus of one end of a string when it is unwound from a circle, keeping it straight. While obtaining points P11, P10, P9, etc., if the length of the tangential line drawn is short, it can be conveniently extended. We have already obtained the various points. To complete the involute, join all these points using a smooth curve. This curve is the involute of the circle. Now we need to draw the tangent and normal. For that, mark point Q arbitrarily, that is random position. So that is Q. Join Q and the center of the circle. On the line connecting point P and the center of the circle, locate the midpoint. Midpoint is M. With M as center and MP as radius, draw an arc like this. M as center, MP as radius, draw an arc like this. Obtain point N where the arc cuts the circle. Join N and P and extend them or extend it to obtain N dash. N dash is the required normal. Draw a line perpendicular to N dash through P, and that is T dash, which is the tangent for the involute at point P. Thank you.